All right, so if you're an engineer, you've definitely seen all the hype around AI agents. But let's be honest, a lot of the demos feel more like magic tricks than engineering. So in this explainer, we're going to skip the magic show and jump straight to the blueprint. We are going to deconstruct AI agents into the architectural components that you can actually build, test, and most importantly, control. This is all about system design.
So let's start with the single most critical idea we're going to talk about. An AI agent isn't some magical monolithic model that you just download. No, it's a system architecture. It's a design pattern that you build. And once you start seeing it as a system that you are in control of, everything else just clicks into place.
And to really bring it down to our level, what is this system? Well, at its core, it's actually shockingly familiar. It's basically a sophisticated while loop that has access to a set of API keys. That's it. No magic. That's the foundation we're building on today.
Okay, here's our game plan. We'll start by really hammering home that an agent is a system. Then we'll dissect it, breaking it down into 3 core organs. After that, we'll see it in action with a real-world flight booking scenario, put all the pieces back together in what's called the cybernetic loop, and then wrap up with the key takeaway for you as an architect.
First up, let's officially deconstruct the magic. This is where we peel back all the layers of hype and just look at the raw components. We're not treating this as some abstract AI problem, but as a classic system design challenge.
The main thing to get is that an agent is really just a composite pattern. Think of it like a container. The large language model, the LLM, is sitting right there in the middle. But here's the kicker. On its own, it's completely inert. It can't do anything. It only comes to life when you place it inside a runtime environment that you build and you control.
To really understand this system, I find it's incredibly helpful to use a biological analogy. So let's take a look at the anatomy of an agent. It can pretty much be broken down into 3 core organs that all have to work together.
First, you've got the brain. This is the LLM. Its only job is to think. It reasons about a problem and it decides which tool it needs to use next. It's a pure decision engine. But, and this is so important, it does not execute anything. It can't click buttons, it can't call APIs, all it can do is plan.
Next up, you have the tools. You can think of these as the system's hands. And what are they? They're just your standard Python functions, your API endpoints, things you already build, like a get flight status function. The brain doesn't know how to implement these things, it just knows how to ask for them by name. The tools are your implementation layer.
And finally, and I'd argue most importantly, we have the control logic. This is the nervous system. This is your code. It's that while loop that connects the brain to the hands. It's what manages state, it's what enforces safety, and it orchestrates the entire process. This is where you, the architect, have the most control and the biggest impact.
Okay, so we've seen the parts. Now let's move to a really concrete example to see how this all comes together. We're going to use a scenario from a fictional airline, Skystream, to show why that control logic isn't just a nice-to-have, it's everything.
So the whole thing kicks off with a simple, but as you'll see, dangerously ambiguous user request. Move me to the evening flight. Seems harmless enough, right? But what does evening actually mean? 6 p.m., 9 p.m., 2 a.m.?
And this leads us to the most critical question for us as systems designers. What happens when we give our powerful brain, the LLM, access to a really dangerous tool, like, say, execute rebooking, but we completely fail to build any guardrails around it?
This image shows the 2 very different paths this can take. Look over on the right first. That's the failure mode. With no guardrails, the brain gets the request, it sees the execute rebooking tool, and it just fires it off. The result? The user is booked on a 2 a.m. red-eye, because hey, that's technically an evening flight. Now look at the safe path on the left. This is where our control logic steps in. It acts as a critical safety check, intercepting the brain's plan and enforcing verification steps before anything gets executed.
In that safe path, the control logic that we wrote enforces an authentication check first. Then it goes back to the user for confirmation. Hey, I found a flight at 7 p.m. Does that sound okay? The failure mode, of course, bypasses all of this. The key takeaway here is that the successful outcome wasn't because we had a smarter brain. It was because we wrote smarter, more defensive code.
So now that we understand just how critical those guardrails are, let's zoom out and see how all these pieces work together in a continuous, controlled cycle. This is what's known as the cybernetic loop.
Most agents operate on a pattern called REACT, which just stands for reason and act. You can think of it like the agent's internal monologue. First, the brain has a thought,
Okay, I need to find the user's current flight first. This thought leads to an action. It outputs a request to call the find_booking tool. Your code then executes that tool and gets back an observation. Booking found, flight UA123. And that observation is then added to the history and fed right back into the loop as context for the very next thought. It's this step-by-step process of discovery.
And here it is, the whole system in one diagram. This is the cybernetic loop in action. The user input goes to the brain. The brain outputs a plan, which is really just a request to call a function. Your code, the runtime executor, handles the actual execution, calls the API, gets a result. That result is then fed back as a new observation, and the loop just continues until the job is done. This is the core engine of an AI agent. And this brings us to the central mantra of agent architecture, the one thing you should burn into your memory. The LLM plans the action. The code executes it. All the power, all the safety, and all the reliability of your entire system comes not from the LLM, but from the execution environment that you design, build, and control.
So let's wrap this up with what I think is the most empowering part, the architect's takeaway. The main message here is that you are not just a passive user of this technology. You are the designer. You are the architect. You are in control. So let's just recap those crucial points one more time. Remember, an agent is an engineered system. It is not magic. The LLM is just the brain, and it's completely helpless without the tools you give it and the control logic you write. Your primary focus as an engineer should always be on that control logic. That's where you build in safety and reliability. At the end of the day, you are the architect. You design the loop, and you build the guardrails.
And that brings us to our final thought. We've deconstructed the magic. We've laid out the architectural blueprint. So the question is no longer, how do these magical AI agents work? The question is now for you. Now that you have the blueprint, what fail-safe systems will you build?